I pose a conceptual physics question to students focusing on optics in this presentation. Without any advanced knowledge of the question and without any time for preparation, their spontaneous and unscripted answers follow. Can you answer the question? So here's the question. As you see from the picture, there's a straw inside a glass of water. The portion of the straw which is above the water line but below the top of the glass is a little bit distorted. And then, of course, the part of the straw which is below the water line looks larger and closer to you than it actually is. Can you explain this using physics and optics? Can you explain this picture? Like why?
Optics is terrible.
Okay.
Let me just say it's the worst thing. It's so important and it's so frustrating because it's just the worst algebra you're ever going to see. What's happening here is two things. One, the surface of the cup is curved, which causes some refraction of the light. And the second thing is that the water has a different index of refraction than air, as does the cup, which causes an additional refraction. So the light that bounces off of the straw in the cup gets distorted as it passes through water, as it changes medium from water to cup and cup to air.
Straw looks different when it's in the water than when it's not in the water. Can you explain?
Isn't that like Snell's law or something, right? That's the name of the law? And like
forget it.
the
It's like-
angle changes depending on the difference in
I think it's just the material.
light. I forgot. I think it might be the diffraction index, some index.
Yes. I think it's just.
It is Snell's law. It's Snell's law.
Yeah.
All right. Good job.
So water has like a different like level of refraction compared to air. So when an object is like submerged in water, it like because like light travels slower, it seems like more like slanted, I guess. It seems like uncentered.
So because light has a different
Yeah.
index of refraction?
Yeah.
Okay. Fine. It looks like that?
That's like a refraction, right?
Refraction.
Yes. So, when there's two kinds of substance, and you want a light to travel from one point to another, like how light travels is not like the directly. It's not like a straight line, but the light will choose the path that requires the lowest. So that they'll try the fastest road to that, and because the speed of light in different substance are different, so you can like calculate like which path will require the lowest time.
That's
Yes.
absolutely correct.
Yeah.
Okay, so here's the explanation. The explanation for this problem involves refraction of light. In this picture, this is the actual position of the straw, and light leaves the straw from everywhere. So we're going to look at one line of light leaving from the bottom of the straw. That line of light travels in a straight line until it hits the interface of the water-air medium, at which case it bends. And the reason it bends is because of refraction. There's a normal. I'm drawing a normal here. When the light gets to the interface, it's going to bend away from the normal, and there's some angle that is made with the normal. This is Snell's law, n1 sine of theta 1 equals n2 sine of theta 2. You may also know this as Fermat's principle of least action. And what happens is, because the water has a larger index of refraction than air, the light will bend away from the normal. And for this reason, when you look into water, objects appear larger and closer than they actually are.